All right, so that's last video talked about defining what the limiting reactant was and limiting reagent was. But now let's see how we use it. Let's say we have a reaction. I'm going to go back to my standby old hydrogen and oxygen producing water. Not a big fan of this equal sign. I should have put an arrow. Anyhow, there's my reaction. Now, let's say that I have two reactants, hydrogen and oxygen. I have a certain amount of each. 1.22 grams of oxygen and 1.05 grams of hydrogen. So I have one and I have a second reactant. Now, to figure out which one limit means, I can't just look at the numbers. I can't say, well, 1.05 is smaller, it's going to be the limiting reactant. Because obviously when we convert from grams of one to moles and then moles to grams, we're going to be using different grams. We're going to be using different conversion factors. So we can't quickly just do that. So what we need to do is we need to compare how much water the hydrogen can make and how much water the oxygen can make. When we see how much the water can be produced by each, then we'll know which one's going to be the limiting. Let's think of it before I solve it. If I solve forward and figure out that there are 10 grams of water produced with 1.22 grams of oxygen, and then I solve from 1.05 grams of hydrogen, it produces 20 grams of water, then I know that this cannot be produced, because once I get to 10 grams, once I have 10 grams produced, there's no more oxygen. I'm out. It's done. There's no more to be able to react with the plenty of hydrogen. So even though I can get 20 grams of hydrogen with this amount of it, water with this amount of hydrogen, I stop once I get to 10. So to figure out which one the limiting reactant is, you need to solve for the same thing, compare those two things, and whichever reactant produces the smaller amount, that's the limiting reactant. Okay, so that's kind of the idea. Let's go ahead and solve. There's no new math at all in it. There's really no new math. It's still just using the stoichiometry, kind of the X line and all that type of stuff. So here's our oxygen. Okay, let's figure out how much hydrogen we can produce. X line, grams O2, moles O2, 132. So I'm going to divide by 32 and I get 0.038 moles of O2. Now I'm going to convert to the moles of water. And again, I'm a big fan of not even worrying or thinking about, am I multiplying, am I dividing by 2, 1, what am I doing? I do labels and then I think about numbers. So moles of O2, that's going to be 1. The H2O is going to be 2. And again, let the labels do your talking. So I see the 2's in the numerator, so I'm going to be multiplying by that. I get 0.076 moles of H2O. 0.076 moles of H2O. Now, moles H2O, grams H2O, 118. Multiply that, and I get 1.37 grams of water. So, with 1.22 grams of oxygen, I can produce 1.37 grams of water. Let's see if I can produce more or less with the amount of hydrogen I'm given. So, here's my hydrogen. I need to convert and compare the two same things. So, X line, grams of hydrogen, moles of hydrogen, 1, 2. Hydrogen off the periodic table is 1, we got 2 of them. So 0.525 moles of hydrogen. X line, moles of hydrogen to moles of water, 2, 2. So it's the same, 0.525 moles of water. Let's bring it down here. 525 moles of water. X line, moles of water to grams of water, 1 and 18. So multiplying those two, what I get? 9.45. So what I'm saying is I can produce 9.45 grams of water or 1.37 when I put these two together. Well, very simply, this is how much I can produce. I cannot produce 9.45 because once I get to 1.37, I'm out of oxygen. There's no more to keep going with the plenty of hydrogen I have. So this, the one that produces the smaller, is my limiting reactant. The oxygen is my limiting reactant. Now, I went forward all the way because a lot of times I have asked the question, what's your limiting reactant and how much grams of water can you produce? Well, there you go. I think that some of us probably said, we could stop right here. If the question was just limiting reactant, once we got moles of water and moles of water, the same thing, so we can compare apples and apples, then we could stop and notice that we have less moles here, so therefore this would be the limiting reactant. And that's totally fine. You can't stop. You can't stop when it's not the same thing. You can't stop at oxygen and hydrogen. You've got to go to the same thing, water and water. I like to go all the way to grams and compare there. Once I see which one's smaller, I know that's the amount I can produce. So that means this one would have been the excess reactant. That's limiting reactant.